Hey everyone, and welcome to The Explainer. Today, we are kicking off something really special. We're diving into a major piece of tech that is actually the focus of an entire 12-part series. We're looking at U.S. patent number 12,664,142, the Hierarchical Script Database. Starting right now, we're going to unpack exactly how this patent completely reimagines database building from the ground up to give us total, absolute transparency. But first, picture this. You've got this massive, highly complex software system, right? It's handling your most critical stuff, your legal contracts, communication logs, financial transactions. But there's a huge catch. You, as a stakeholder, are completely locked out. You can't audit the data, you can't verify the functions, it's a complete black box. How on earth do you know the data is accurate? How do you know it hasn't been maliciously tampered with? You can't. That inability to verify is a massive vulnerability, and solving that exact issue is why this patent is poised to absolutely disrupt industries that currently rely on blind trust. So, here's our roadmap for today. First, we'll look at the transparency problem, then the patented solution. Third, we'll cover code and data together, then growing the tree, and finally, we'll look at some real-world applications. Let's start with Section 1, the transparency problem. You know, modern database trends have just exploded into massive code sizes, insane complexity, and unbelievably high data volumes. Usually, these systems use compiled code, which, let's be real, is totally opaque to the average user. That's the prior art this patent is going up against. Trying to verify that functions are computing correctly in those opaque databases takes a ridiculous amount of effort and heavy technical expertise. On the flip side, we have the vision of this patent, a transparent script database. Instead of hiding behind compiled binaries, this system uses human-readable text, scripts, running right inside an interpreter environment. It makes the whole database self-explanatory. And the patent's background text hits the nail on the head here. It points out that developers are usually pretty reluctant to share the nitty-gritty details with novice stakeholders, quote, preferring to adopt a trust me posture, unquote. I mean, trust me, that's not just annoying. That is a massive security risk. Malicious tampering inside a black box is basically invisible. Which brings us to Section 2, the patented solution. This officially granted patent introduces a fundamental shift. Instead of locking up the logic and data in compiled code, it builds the database using simple scripts, think JavaScript or JSON, that run in an interpreter environment. These are just plain text files in a directory. Anyone with basic access can just open the file and literally read what it's doing. And this isn't just a neat technical trick, it's a huge legal win too. Software patents face intense scrutiny, but this architecture easily survives the rigorous Alice framework for patent eligibility. Why? Because using this interpreter environment creates a concrete structural improvement to computer functionality. It's not just an abstract idea. It replaces blind trust with absolute self-explanatory transparency. Moving to Section 3, code and data together. Okay, so how is this organized? Information here is stored in nodes, acting as vertices of a tree topology. But a node isn't just some passive bucket waiting around for a distant server to query it. It's an active script representation containing both the function properties, the executable code, and the data properties, right there, side by side. Organizing it this way leverages the strict mathematics of tree topology, making data retrieval incredibly efficient and predictable. Because the code and the data live together in the exact same script, the database basically explains itself. Think of it like a giant, totally transparent filing cabinet. In a regular cabinet, you have folders full of data, and the rules for handling them exist in some office manager's brain. But here, the rules for the files and the data itself live side by side, perfectly visible on the very same page. Section 4, growing the tree. So how does this tree actually grow dynamically? It all starts when an event arrives. Step 1, an existing parent node, acting as an event handler, gets an event from an interface module. This just means, hey, we need to insert a new data item, like a new logged phone call or a new paragraph in a contract. Next up, Step 2. The parent node executes its script to instantiate a brand new child node specifically to hold that new data. Then, it grabs its own unique identifier plus the new child's identifier and passes them both straight to a kernel function. Finally, Step 3. The kernel function takes over and adds metadata, basically a namespace address or handle to both the parent and the child. This permanently links them together within the tree data structure. The parent now knows exactly where to find its new child, and boom, the tree has successfully grown. Just to lock that in, it's a super trackable 3-step cycle. 1. Receive the event. 2. Instantiate the child node. 3. The kernel function writes the metadata to link them. This process can happen endlessly, letting the database grow without bound, governed entirely by the strict mathematics of its topology, limited literally only by your hardware. Section 5. Real-world applications. Let's apply this to a real market disruption. The patent gives a great example of a music licensing database. Imagine a single tree managing an entire music ecosystem. You've got text nodes managing the legal contracts, you've got song nodes containing industry-standard metadata for every track, and then beneath those, you have transaction nodes. These are write-only audit trails that systematically log every single time a song is performed or a royalty gets paid out. Because every single one of those nodes is written in plain text script alongside its own processing rules, the whole system prioritizes verifiability. You don't need to be a database engineer, a musician, a lawyer, a distributor. They can all visually audit these trails intrinsically. Empowering everyday stakeholders to do that is exactly how this transparent architecture completely disrupts traditional gate-kept tech markets. Now, you might be wondering, won't logging endless transactions cause massive float? The patent handles that beautifully. The system uses query events to extract data for reading, but it also has maintenance commands. You can literally just send a command like purge Jan 1, 2019, and it'll systematically traverse the tree and delete the stale nodes. And to make sure you don't accidentally delete the important stuff, core routing nodes can be tagged with permanent flags to protect them. It really is a remarkably elegant system. When you stack this up against 250 years of prior art at the Patent Office, this specific combo of plain text scripting and tree topology stands out as a genuine verifiable breakthrough. It's a massive shift away from those opaque black boxes, bringing trust and verifiability right back to the user. So that leaves us with a pretty compelling question. As our data gets more and more critical, is this kind of transparent, self-explanatory architecture the absolute future of software? We're going to continue exploring that exact question throughout the rest of this 12-part series. Thank you so much for joining me, and I'll see you in the next explainer.